Erik has 4 bricks of the same size. Okay, these are the 4 bricks. Which of the cubes shown below can he make with his 4 bricks? All right. So notice that he has 1 white and 1, 2, and 3 gray bricks. So let's keep that in mind. Let's look at choice A. It has only 1, 2 gray bricks. So this is not possible because we need 1, 2, and 3 gray bricks, right? So here also 1, 2, only 2 gray bricks. So this is not possible. Here 1, 2, and 3. There are 3 gray bricks. So this looks like a good choice. Let's take the other ones. 1, 2, only 2 gray bricks. So this is not possible. 1, 2, only 2 gray bricks. This is also not possible. Then C is the correct choice. How many fish will have their heads pointing towards the ring when we straighten the line? All right, to explain it better, so let me draw a straight line with a ring. So this is a ring. I draw a fish. So this fish is pointing towards the ring. I draw another fish. So this fish is pointing away from the ring. Now notice that when I travel from the ring, if the fish is pointing towards the ring, the head, I will come across the head first and then the tail. But if the fish is pointing away from the ring, I first come across the tail and then the head, right? So this is pointing towards, this is away, right? Okay, so let's keep that in mind. All right, so let me start traveling from the ring. If I go like this fish, I come across the head first. So this will be pointing towards the ring. This is tail first. So this is not going to work. Head first. So this is going to work. Tail first. Not going to work. Tail first. Not going to work. Head first. So this fish will be pointing towards the ring. Head first. This will be pointing towards the ring. Head first. This will be pointing towards the ring. Tail. Not going to work. Head first. This will be pointing towards the ring. So total of 1, 2, 3, 4, 5, and 6. Then C is the correct choice. When you put 4 puzzle pieces together correctly, they form a rectangle with a calculation on it. What is the result of this calculation? All right, so let me first draw the rectangle. Like so, and make room for the 4 puzzle pieces. All right, notice that one has the left edge flat, and that must go here then, because the left edge here must be flat, right? So one must go there. Similarly, 2 has the right edge flat, and this end piece must have the right edge flat, so 2 must go there. All right, so 1 and 2 are already taken into account. So 1 has this pointy thingy, so let me draw that here. 2 has this hole on this side, so 2 has a hole there. Okay, now a piece that has a hole must go here. So the remaining are 3 and the plus sign. So 3 is the one that has a hole, so 3 must go there. But if I put 3 there, it has hole on the other side too, right? All right, now the only remaining piece is plus, so the plus should go there. But let's double check. Plus should have 2 pointy thingy on both ends, so it has 2 pointy thingy on both ends. So this is the correct way of putting the puzzle pieces. Now once we do that, it is a fairly simple calculation. It is 13 plus 2 is 15. Then B is the correct choice. Alaya draws a picture of the sun. Which of the following answers is part of her picture? All right, so we can check each answer one at a time. For problems like this where you have to match a pattern, right, it always helps to pick a direction. For example, we can go clockwise or anti-clockwise. I'll just pick clockwise, and we have to pick the same direction for the choices also. So we'll also go clockwise here. So we have to find here 2 big blacks followed by 2 small whites. There are 2 big blacks here, but there is only 1 small white. Here 2 big blacks, there is no white. This is a gray. So clearly A is not possible. Okay, let's check B. There's a big black, gray, small white, and then big black. Let me check, scan through it. Okay, I see a big black, gray, white, and then big black. So if I number this 1, 2, 3, and 4, you can see that this is 1, 2, 3, and 4. So this pattern is matching with this pattern. So this seems like a possible choice. Similarly, we can scan through the remaining choices and see that this is the only choice that matches. Then B is the correct choice. 5 boys competed in a shooting challenge. Ricky scored the most points. Which target was Ricky? So these are the 5 boys. 1, 2, 3, 4, 5. So we want to find out which has the most points, right? So we can simply add it up. So in this case, I have a 10. So this is a 10. And then this is a 8. And this is a 7. So 10 plus 8 is 18 plus 7 is 25. All right, so in this case, I have a 10 plus, these both are 7. 10 plus 7 plus 7. So this is going to be 7 plus 7 is 14 plus 10 is 24. All right. So here I have 8, 8, 8. There are 3 8s. So 8 times 3 is 24. In this case, I have this is a 8, and then there are 2 7s plus 7 plus 7. So this is going to be 22, right? 7 plus 7 is 14 plus 8 is 22. So here I have a 9 and another 9. So 9 plus 9 plus 8. So this is 18 plus 8 is 26. So we want the most points. So out of all this, 26 is the highest, then E is the correct choice. A measuring tape is wrapped around a cylinder. Which number should be at the place shown by the question mark? Alright, so this is where the question mark is. So what number should go there? So basically, if I can figure out how long it is to go one time around the cylinder, I'm all set, right? Okay, so we have some data given here. Let's say if I go one time around from 6, then I reach at 27, right? So from 6, if I go one time around, I reach at 27. So how long that would be? That would be 27 minus 6 is equal to 21, right? And same would be true at any point. For example, let's say if I start at 8, if I reach at 29, 29 minus 8 is 21. So it is 21 units long to go one time around the cylinder. Then if I start at 27, where will I end up? So basically 27 plus 21, right? Because it is to go one time around the cylinder, it is 21. We already figured that out. So 27 plus 21 is 48, right? So 48 should go at the question mark. Then C is the correct choice. Dennis fired a silver and a gold rocket at the same time. The rockets exploded into 20 stars in total. The gold rocket exploded 6 more stars than the silver one. Okay, gold rocket exploded 6 more stars than the silver one. How many stars did the gold rocket exploded into? Okay, so let's say G for gold and S for silver. Okay, so gold rocket exploded into 6 more, right? So let me first take away 6 from 20. Okay, so the remaining is 20 minus 6 is 14. Okay, so if I divide 14 into 2 equal parts and give it to each, and gold already has 6, then gold will have 6 more, right? So 14 by 2 is 7. Let me give 7 each to gold and silver. So the gold will have 13 and silver will have 7, right? And as you can see, if I do it this way, the gold already has 6 more, right? So gold rocket exploded into, then 13. D is the correct choice. You can also solve this problem using algebra. So silver and gold, they exploded into 20 stars. So S plus G is equal to 20. Okay. And then gold rocket exploded into 6 more stars than the silver. Then gold is equal to whatever the silver is plus 6. Let me call this equation 1. Let me call this equation 2. Okay. Now I'm going to substitute G here. So I'm going to rewrite equation 1. S plus G. G is S plus 6 is equal to 20. Right. So this S plus S is 2S plus 6 is equal to 20. I subtract 6 from both sides. So 2S is equal to 20 minus 6 is 14. Now I'm going to divide both sides by 2. Then this is going to be S, and 14 by 2 is 7, right? So S is equal to 7. Now if I substitute the value of S in here, I can find gold, right? So gold is equal to silver is 7. 7 plus 6 is 13. Is the same answer as before. Rosana has some balls of 3 different colors. Balls of the same color have same weight. Okay, what is the weight of each white ball? All right. So these are the different settings of the balls, and the weights are written in the box there. So as you can see, this is a gray and a black, right? Gray and a black is 6 kg. I can see that there is a gray and a black here. So this is 6 kg, right? That is from here. Now, if this is 6, then what would be the gray? Because this total is 10 kg. So this must be then 4, right? Then 6 plus 4 is 10, right? Okay. So if this is 4, so this is going to be 4 then. Same gray, same color have the same weight, right? So if this is 4, what will be this, right? So this total is 14. 14 minus 4 is 10, and I have 2 of white balls, right? So 10 by 2 is 5, right? So this total is 10. Then each white ball will be 5. This will be 5, right? Then C is the correct choice. You can also solve this using algebra. This is how. Here, let me call G for gray. Gray plus black is equal to 6, right? From this, I have 2 white, W for white, plus G for gray is 14. And this is 1 black plus 2G is equal to 10, right? So this is equation 1, equation 2, equation 3. And this is nothing but I have just written down what I see here in equation 4, right? So from here, from equation 1, let me express B in terms of G. From here, B is equal to, I take G to the other side, it will be 6 minus G, right? What I'll do now is I substitute B here. So here, B is equal to 6 minus G, 6 minus G, and then plus 2G. This would be 10, right? So minus G plus 2G, so that is just G, and then I take 6 to the other side. So 10 minus 6, this is going to be 4, right? So gray is 4, all right? If gray is 4, B is going to 6 minus 4 is equal to 2, right? B is 2, right? So I need to find W. So let me use this equation. I already know G is 4. Gray is 4. So 2W plus 4, 2W plus 4 is equal to 14. I take 4 to the other side, and this gives me 2w is equal to 14 minus 4 is 10. So this gives me, if I divide both sides by 2, 10 by 2 is 5, w is equal to 5, and we get the same answer. Nisa has 3 different types of cards in a game: apple, cherry, and grapes. Okay. She chooses 2 cards from the set and swaps their place. She wants to arrange the cards so that all the cards with the same fruit are next to each other. The same fruit are next to each other. For which set this is not possible, right? For which set it is not possible. All right. So we want, for example, in A, we want the apples together and the grapes together. So let's see if I can make any swap. If I swap apple and grape, the grape is going to go far away, right? So it seems like this is the one that is not possible, but let's check the other ones. For B, I want apples together. So if I swap apple and cherry, right? So apple, 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 this is grape and cherry, that is fine because grape and cherry are 2 different fruits. So that's totally fine. In this case, if I swap, I want the apples together and the grapes together. So how about if I swap these two, right? Then grapes will be together here, grapes, and apple will be together. Cherry is a different fruit anyway. For this case, there are 3 cherries, so I want the cherries to be together. So I am going to swap apple with cherry. Then all the cherries will be together, and apple and grapes are different. In this case, I want the cherries together and grapes together. Okay, so what I can do is I can swap like this, right? So grape will be here, so grapes and grapes are together, cherry will be here, they are together. So for B, C, D, and E, I can make one swap to keep the same kind of fruits together, but for A, I cannot do that. Then A is the correct choice. Sophie wants to pick 5 different shapes from the boxes. She can pick only one shape from each box. Okay, pick one shape from each box. Which shape she must pick from box 4? All right. So as you can see, box 3 has only one shape. So we must pick the circle from there, right? So circle is gone. Circle from box 3. Okay, let's see. Circle. Okay, let's look at box 1 now. Circle combines with star, right? So we must pick the star from box 1. So I can also rule the star out. Okay. So circle and star gone. If we look at box 5 now, star is already taken, right? Star is already picked. Then the pentagon I must pick from box 5. Okay. So I must pick the pentagon from box 5. All right. Now I have already picked 3 shapes. Now if we look at box 4, star is already picked, right? Pentagon I have already picked. Circle I have already picked. Only thing that is remaining is the diamond. So from box 4 then, diamond is the only choice. So which shapes you must pick from the box? It must be a diamond. 18 cubes are colored white, gray, or black are arranged as shown. All right, so this is how they are arranged. The figures below show the white and the black parts. Which of the following is the gray part? All right. Okay, if we look at this picture, the top layer is all taken by the black and the white, right? So we will get nothing from the top layer remaining, right? So let me draw the bottom layer then. This is the bottom layer. The top layer is all taken by the black and white. So I'm drawing only the bottom layer. Now, if I look at the white parts, it is present both in top and bottom, right? The black is only on the top layer. It is already accounted for here, and we don't need to worry about that. From the white one, I can see that these two are basically these two, right? So what is remaining from the bottom layer are these two, right? So these two, which is same as these two, must occupy these two space, right? All right. So what is remaining then? What is remaining is this, right? So this is what is remaining, right? So which one of these matches with this? This definitely doesn't. This doesn't. This doesn't. This doesn't. This matches with that, right? But this is choice E, right? So this is choice. This is basically choice E, right? So this is the correct choice. The 5 balls shown begin to move simultaneously in the directions indicated by their arrows. These are the 5 balls. When the 2 balls going in opposite direction collide, the bigger ball swallows the smaller one and increases its value by the value of the smaller ball. Okay, so the bigger swallows the smaller. The bigger ball continues to move in its original direction as shown in the following example. All right, 11 and 4, they're going in the opposite direction. So when they collide, 11 consumes 4 because 11 is bigger than 4, and 11 was going to the right, so 15 continues to the right. Okay, what is the final result of the collisions of the 5 balls shown? All right, so these are the 5 balls, right? So in the beginning, 9 and 3, they are going in the opposite direction and they collide. 9 is bigger than 3, so 9 will consume 3. So 9 will become 9 plus 3 is 12, right? So 9 will become 12 and will continue towards right. Okay, then 12 and 7, they will collide because they are going in the opposite direction, and then 12 is going to consume 7 and 12 will become 12 plus 7 is 19, right? And it will still continue to the right. Okay, then 19 and 20 are going to collide. In this case 20 is bigger, so 20 is going to consume 19 and this will become 20 plus 19 is 39, and it will continue towards left because 20 was going towards left. All right, next 39 is bigger than 10, so 39 is going to consume 10, so 39 will become 39 plus 10 is 49, and it will continue towards left because 39 was bigger, right? So the final result we are left with is 49 towards left. Then C is the correct choice. In an ice cream shop, there is some money in a drawer. After 6 ice creams were sold, there were 70 euros left in the drawer. After a total of 16 ice creams were sold, there were 120 euros left in the drawer. How many euros were there in the drawer at the start? All right. So in the beginning, we had some money we do not know, so I'll put a question mark. Then after selling 6 ice cream, 6 ice cream, we had 70 euros. 70 euros. All right. Then after a total of 16 ice creams, okay, so this is the 6 ice cream, then we sell a total of 16 ice cream, but this is total. This is also total, right? Initially we had some money, we sold a total of 6 ice cream, 70 euros, and then we sold a total of 16 ice cream. So this 16 ice creams includes this 6 ice cream. We need to remember that. And then we ended up with 120 euros. All right. So let's take a look at this part of the transaction, right? How many, from here to here, how many ice creams we are selling? We had already sold 6, right? Here total of 16, so we must have sold 10 more ice creams here, right? So 10 ice cream, but how much money we got? We got 120 minus 70, that is 50 euros. All right, so okay, we sold total of 10 ice creams, we got 50 euros for that, right? So one ice cream must be 50 by 10 is equal to 5 euros. All right, okay, so that is from this part of the transaction. So we know one ice cream is 5 euros. So here we sold total of 6 ice creams. So 6 ice creams will be then 6 times 5 is equal to 30 euros. All right. So when you sold 6 ice creams, you might have gotten 30 euros, right? 30 euros. So we had some money plus 30 euros. We ended up with 70 euros. So how much money we had? Basically 70 minus 30, right? So 70 minus 30 is 40 euros. So we had 40 euros to start with. We sold 6 ice creams, one for 5 euros. So we got 30 euros. So 40 euros plus 30 euros is 70 euros, right? All right. So how many euros were there in the drawer at the start? At the start, we must have 40 euros, right? Then C is the correct choice. The koala ate some leaves from 3 branches. Each branch had 20 leaves. The koala ate a few leaves from the first branch and then ate as many leaves from the second branch as were left on the first branch. Okay? Then it ate 2 leaves from the third branch. How many leaves in total were left on the 3 branches? Okay? So let me write down, make a small table. Branch 1, branch 2, branch 3, and here how many leaves it ate and how many were left. Okay, simple table. Okay, it ate some leaves from branch 1 and I don't know how many. We can just assume some number, right? Let's say it ate maybe 5 leaves, right? So how many were left? So 20 minus 5 is equal to 15 were left, right? So from the second branch it ate, how many were left from the first branch? 15 were left, right? So it ate 15 from the second branch, right? Then how many were left? So 20 minus it ate 15, so this would be 5 were left, right? All right. Then from branch 3 it ate 2 leaves. It ate 2 leaves, so it started with 20 minus 2, so 18 leaves were still left. So how many leaves in total were left in 3 branches? So the total is 15 plus 5 is 20 plus 18 is 38. All right. So note that we assumed some number here. I assumed it ate 5 leaves from the first branch, but we don't know. Now you can assume a different number. Maybe start with 3, 2, 7, 12. Assume a different number here and make sure that you get the same answer. You should get the same answer, but that I leave that to you as an exercise. Assume a different number here and make sure that you get the same answer, right? Then E is the correct choice. We can also do this in an algebra way. So let me show you how to do that. All right. So I don't know how many leaves it ate from the first branch. I'll assume it to be X. It ate X amount of X number of leaves. Then how many were left? 20 minus X were left, right? So each branch has 20 leaves. It ate X. So what was left is 20 minus X. So from the second branch, then it ate as many leaves from the second branch as were left on the first branch. So first branch has 20 minus X left. So it must eat 20 minus X from the second branch, right? So how many leaves are left here? 20 minus, how many it ate? 20 minus X, right? So this will be 20 minus 20 will be 0, and then this negative sign will become positive. So this will be X, simply X, right? So this will be X. Okay. All right. Now from branch 3, it had 2 leaves, right? So it had 2 leaves. So 20 minus 2 is equal to 18. 18 were remaining, right? So how many leaves in total were left in 3 branches? So we add it up. So 20 minus X, X, and 18. So you see that if you add 20 minus X plus X, X and X will cancel out. So there will be 20 here, right? 20 plus 18 is 38. So regardless of how many it ate from the first branch, right? It can be 2, 3, 5, any number. We will always end up with 38. Then again, we end up with the same answer. On a tall building, there are 4 fire escape ladders as shown. All right, this is a building. The heights of 3 of the ladders are at their tops. Okay, height of 3 ladders are known. What is the height of the shortest ladder? So there is a question mark. We need to find the height of that. We can actually use simple geometry to compute this, right? So what is going to be this height? This is going to be, see, they have the same base. So this is going to be 48 minus 36, right? So this is 48, this is 36. So the difference is going to be 48 minus 36 is equal to 12. All right. So on this side, these 2 ladders have the same base, right? We know that this is 32, right? We need to calculate this side. We don't know this yet, but we know this. So this is going to be the same as this, right? The difference here is same as difference here, right? So that is going to be 12. So what is this side then? 32 minus 12, right? So this is going to be 32 minus 12 is 20, right? Then D is the correct choice. Nora plays with 3 cups on the kitchen table. She takes the left hand cup, flips it over and puts it on the right of the other cups. Okay, the picture shows the first move. What do the cups look like after 10 moves? Okay, so this is the first move. It takes the left, flips it over and puts it on the right. Okay, it's going to be difficult to keep drawing the cup all the time, so I'm going to just draw some arrows. So this is like, these are the cups pointing up. Okay, so this is the first move. In the first move, it goes there, right? So this will be up, up, and then down. So this is the first move. In the second move, this will go here. So this will stay, this will be down, this will be down, right? This is the second move, right? Now the third move, this will go to the right. So this will be down, down, and this will be down again. This is the third move, right? So as you can see, every third move, all the cups are flipping, right? So in the sixth one, they will be all up, right? Because in the fourth, this will flip, fifth, this will flip, sixth, this will flip. So by the sixth move, all 3 would have flipped up again. Similarly, in the ninth, everyone will be down again, right? All the 3 cups will be down. Now we want to find out after how many? After 10 moves, right? So in the next move, basically, this is going to flip over there. So this will be down, down, and up, right? So the choice is down, down, and up. B is the correct choice. Eva has 5 stickers shown. She stuck one of them on each of the 5 squares on this board. All right. So that star is not on square 5. Okay. Cherry is on square 1 and flower is adjacent to circle and triangle. On which square did Eva stick the flower? Okay. Okay. So let me draw the board. 1, 2, 3, 4, 5. It says star is not on square 5. So the star cannot be here. So star must be in one of this. Star must be in one of this. Okay. Cherry is on square 1. All right. So let me draw the cherry. So cherry is on 1. That means star cannot be here. Okay. So star has to be on either 2, 3, or 4. Okay. Flower is adjacent to circle and triangle. So the flower have to be adjacent to circle and triangle, right? The circle can be here or here, but it doesn't matter, but they have to be together. These 3 have to be together, right? These three have to be together, right? Now we know that we cannot put the star on 5, right? It has to be on 2, 3, or 4. But these three have to be together. But I have to accommodate star and have 3 spaces available together, right? So that means star has to go here. Then I have these 3 spots available for these 3. Now, regardless of whether the circle is on this side or triangle is on this side, as you can see, the flower is always going to end up on square 4, right? Then D is the correct choice. 7 cards are arranged as shown. All right, this is how. Each card has 2 numbers on which one of them written upside down. The teacher wants to rearrange the cards so that the sum of the numbers in the top row is same as the sum of the numbers in the bottom row. Okay, so we want to rearrange so that the sum of the top row is same as the sum of the bottom row. Okay, she can do this by turning one of the cards upside down. Which card must she turn? Okay, all right, so we want to turn one card so that the sum on the top is going to be the same as the sum of the bottom. Let's find the current existing sum, right? So this row adds up to 7 plus 5 is 12, plus 4 is 16, plus 2 is 18, plus 8 is 26, plus 3 is 29, plus 2 is 31. Okay, the sum here is 4 plus 3 is 7, plus 10 is 17, plus 14 is 31, plus 4 is 35. All right, so the current sum of the top row is 31, current sum of the bottom row is 35, right? And we want both the rows have to have the same sum, right? Then if we want them to have the same sum, it will be average of these two numbers, right? So these two add up to 31 plus 35 is 66. So 66 divided by 2 is 33. So basically we want both the top and the bottom rows to add up to 33 each, right? All right, so we are already at 31 here, 35 here, right? So basically we want this to be 33, this to be 33, right? Now we need to find a card that has 2 more on the bottom, and if we flip it, it will be fine. That is what we want, right? If there's 2 more on the bottom, then we will take away 2 from here, so 35 will become 33 and 31 will become 33 also. So let's try to see which card has 2 more in the bottom. So this is 3, difference is 3. This will not work. Here the bottom is less, will not work. Here again, the difference is 1, it will not work. All right, so 2 and 5. So again the difference is 3, is not going to work. 7 and 8, the difference is 1, is not going to work. 3 and 7, again the difference is 4, is not going to work. 2 and 4. As you can see, the bottom card is 2 more. So if we flip this, right? So this is going to be 4, this is going to be 2. Then what we'll end up with, this 33 will be 31 will become 33, and this will be 2 less, it will also be 33. Then we must flip the card G, then E is the correct choice. The numbers 1 to 9 are placed in the square shown with a number in each square. Okay, the sum of all the pairs of neighboring numbers are also shown. Okay, so this is the sum that are shown. Okay, which number is placed in the shaded square? So this is the shaded square. Notice that we are only given the sum of 2 numbers. So if we know one of the numbers, we will know other numbers. For example, let's say the sum is 10, right? So something plus something is equal to 10. If I know one number, right, just for the sake of example, let's say 3, then I know the other number, right? So if I know one number, I know the other number. Okay, and we also know that the numbers are between 1 to 9. They cannot be anything, right? So one way to do this is, the 1 can go in one of the squares, right? So once we place 1, and since we know the sum of adjacent squares, we can try finding the other number and so on, right? Or we can, for this cell, we can try all the numbers 1 to 9, right? But if I put 1 here, let's say if I have 1, then this sum is going to be 15, so this has to be 14, but the numbers have to be between 1 to 9, so this cannot be 1. Okay, so 1 2 3 4 5 6 7 8 9, I'm just writing it down, and I'll check one of these numbers one at a time for this square. Okay, so we just found out it cannot be 1. What if I put 2 here? If I put 2, this will be 13, right? So 2 plus 13 is 15, but they have to be between 1 and 9. So similarly, it cannot be 2. Similarly, it cannot be 3, it cannot be 4, it cannot be 5. 6 is a possibility, right? If it is 6, this has to be 9, right? Then it is going to be 15. 6 plus 9 is 15. But these two sum has to be 7. So this will be then -2, right? So 9 plus -2 is 7, but the number cannot be negative, right? It has to be between 1 and 9. So it cannot be 6 either, right? Right? So how about 7? If I put 7 there, this is going to be 8, right? Again, 8 and 7, so this has to be -1 for the sum of 8 and -1 to be 7, right? But again, that cannot happen because the numbers are between 1 and 9. So 7 isn't going to work either. How about 8? If I had 8 here, this will be 9, right? No, this will be 7, right? 8 plus 7 is 15, right? Now, if it is 7, this must be 0, right? But it cannot be 0. It has to be between 1 and 9. So 8 also is not going to work. So this has to be 9 then, right? There is the only one left. So if it is 9, then this is going to be 6, right? If this is 6, this has to be 1. So 6 plus 1 is 7. If this is 1, this has to be 2. 1 plus 2 is 3. If it is 2, then this is to be 7. 7 plus 2 is 9, right? Now if it is 7, this has to be 8. 7 plus 8 is 15. And 8, this has to be 3. So that 8 plus 3 is 11. And if it is 3, this has to be 5. So that 3 plus 5 is 8. And then this has to be 4. Then 5 plus 4 is 9. And as you can see, all digits we have used only one time. 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So the gray must be 7. There is actually one more way we can try this. Remember, we are only given the sum. So if we start with this lowest sum, there is limited possibilities. What do I mean? Let's say we start with 10, right? 10 can be 1 plus 9, it can be 2 plus 8, and so on and so forth. There are going to be more choices. But if we start with the smallest sum, say 3, there are only two choices, 1 plus 2 or 2 plus 1. The choices are very limited, right? Okay, so if the sum is 3 here, this cell can be 1 or 2. So we need to try only two different choices. First, let's assume this is going to be 1. If this is 1, this must be 2, and this has to be then 7, right? 7 plus 2 is 9, and then this is 8. 7 plus 8 is 15, and this is 3. 8 plus 3 is 11, and this is 5. 5 plus 3 is 8, and then this is 4. 5 plus 4 is 9, and on this side, this must be 6. 6 plus 1 is 7, and this will be 9. 9 plus 6 is 15. All right, so seems like 1 is going to work, but let's check 2. What if this cell is 2? So if this is 2, then this is going to be 1. This is going to be 8. So 8 plus 1 is 9. This is going to be 7. So 7 plus 8 is 15. This will be 4. 7 plus 4 is 11. This will be 4 again. 4 plus 4 is 8. But in digit cannot repeat, right? So 4 plus 4 is not going to work. So this cannot be 2. Then the earlier choice of 1 was the correct choice, and that led to this number to be 7. Remember, if this was 1, this was going to be 2, then 2 plus 7 was 9, then again, same. We arrive at the same answer. Mia throws darts at balloons worth these points. She scores 30 points in total. Which balloon does Mia definitely hit? Alright, so these are the balloons with different points, and I need a total score of 30. So basically, I need to find different ways I can add these numbers to get to a total score of 30, right? Alright, so let me start with one of the balloon, let's say 18. How many more points do I need to get to 30? 18 plus 12 is 30, 30, right? But there is no balloon with a point of 12, right? So how can I get to 12? I can use 9 and 3, right? 9 plus 3. Alright, so 18 plus 9 plus 3 will get me to a total score of 30, right? So let me write it down. 18 plus 9 plus 3. So this is one way I can get to a total score of 30. Okay, is there any other way I can get to a total score of 30? Alright, I have not used 14, so let me try with 14 now. 14 plus what number will get to 30? 14 plus 16, right? 14 plus 16 is 30. Alright, but there is no balloon with points 16, right? So I need to see if there is another way I can get to 16. 16 would be 13 and 3, right? So 13 plus 3, right? So this is another way I can get to 30. That is 14 plus 13 plus 3, right? So I have used 14, 13 and 3. So 14, 13 and 3. Okay, I'm just marking the balloons that I have already used. Alright, so by now I have used all the different numbers, right, to get to 30. So, and since like these are the only two ways I can get to a total score of 30, and in both the ways, as you can see, I've used the balloon with 3 points, right? Then that is what we need to find out. Which balloons does Mia definitely hit? So Mia definitely hits balloon 3, which is A is the correct choice. A box has fewer than 50 cookies in. The cookies can be divided evenly between 2, 3 or 4 children. However, they cannot be divided evenly between 7 children because 6 more cookies would be needed. How many cookies are there in the box? Alright, so we have less than 50 cookies and they can be divided evenly between 2, 3 or 4. 2, 3 or 4 kids, it can be evenly divided. Alright? Alright, so the number of cookies have to be a multiple of 2, 3 and 4. Right? And what is the lowest multiple of 2, 3 or 4? So that is the LCM, right? So LCM of 2, 3 and 4 is 12, right? So it can be 12, 24, so on and so forth. So let me write down those numbers, okay? So it can be 12, it can be 24, it can be 36, it can be 48, 60, right? But it cannot be 60 because we need less than 50 cookies, so this is not possible. So any numbers more than that is not possible. So it can be 12, 24, 36 or 48 cookies in the box, right? But we have another condition, right? But they cannot be divided. They cannot be divided evenly between 7 children because 6 more cookies would be needed, right? All right. So let me try to find the multiple of 7 that is next multiple of 7 that is more than these numbers, right? So what is the multiple of 7 that is just larger than 12? So that is going to be 14 here. So in this case, I would need 2 more cookies, right? And this is the multiple of 7 that is just greater than 24 is 28. In this case, I would need 4 more cookies, right? Right? And the multiple of 7 that is just greater than 36 is 42. In this case, I need 6 more cookies. And then the multiple of 7 that is just greater than 48 is 49. And in this case, I would need 1 more cookies, right? All right. Here I have written down the multiples of 7 that is just larger than these numbers, right? So 14, 28, 42, and 49, right? And in each case, I have written down how many more cookies I needed, right? For it to be evenly divided with 7 kids, right? But it says 6 more cookies, right? So we needed 6 more cookies. So that is this, right? So the box must have 36 cookies, right? So that it can be evenly divided between 2, 3, and 4 kids, but we would need 6 more cookies to be evenly divided between 7 kids, right? Then 36, that is D is the correct choice. Each of the 5 boxes contain either apples or bananas, but not both. The total weight of all the bananas is 3 times the weight of all apples. Okay? Which box contains apples? Alright? So, we have some apples, right? And we have some bananas, right? The weight of bananas is 3 times the weight of apples. Okay, let's say the apple weighs, we don't know how much, but it has some weight. Then the banana is 3 times of this, right? So banana would be 3 times of this. This box represents the weight of apple, and banana is 3 times, so 3 boxes, right? Alright. So all the 4 weights together has to be the sum of all these 5 numbers, right? So let me try to find the sum of these 5 numbers. So this is 7 plus 5 plus 6, 7, 5, 6, 2 and 16. Plus 2 plus 16. Alright, so this is 7 plus 5 is 12, plus 6 is 18, plus 2 is 20, plus 16 is 36. Okay, so this is the total weight of all the boxes, right? And the total weight must be sum of these two, right? Whatever apple is, and then 3 times that banana. So the 4 parts, 1, 2, 3, 4 parts contribute to 36. So one box must weigh 36 by 4 is 9, right? Right? So one box must weigh 9. 9, 9, 9, 9. So that, banana is 3 times the weight of apples. Alright? Okay. Now, which box contains apple? So, apple must weigh 9 kg, right? Apple must weigh 9 kg. And we know that, each box contains either apple or bananas, but not both. So, we have to find the boxes that add up to the number 9, right? So, let's see. If we just look at the number, we can see that the only way we can add the boxes is 7 plus 2, right? 7 plus 2. These are the only 2 boxes that we can add up to 9, right? So then these 2 boxes must contain the apples, right? Because that is the only way we can get 9. So this is like box 1 and box 4, then E is the correct choice. You can also do this problem using algebra. We can assume the weight of apple is, let's say, A, right? And then banana is 3 times the weight of apples, then B is equal to 3A, right? And then the total weight is A plus B, that is the total weight, right? That is 36, we already found that out here, right? But we know that B is 3A, so A plus 3A is equal to 36. This implies 4A is 36. 4A is 36. then A must be 36 over 4 is 9, right? We get at the same answer. So banana is, apple is 9 kg, and then we see that only these two boxes give us 9 kg, and then we get the same answer, of course. Elena wants to write numbers from 1 to 9 in the squares shown. All right, here. The arrows always point from a smaller number to a larger one. She has already written 5 and 7. Which number should she write instead of the question mark? All right, so which number goes here? Okay, so let me write down the numbers from 1 to 9 so that it is easy for me to track. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 5 and 7 are already gone, right? 5 and 7 are already taken. All right, and the arrows always point from a smaller number to a larger one. So if we look carefully, if this is 5, this has to be a number less than 5 because the arrow is pointing from here to here. So this number must be less than 5. Similarly, this number must be less than this number. So this number is also less than 5. Okay. This number is less than this number. So this number must also be less than 5. Right? If we come here now, this number must be less than this number. So this number also is less than 5. Right? Okay. So as you can see, these 4 numbers should all be less than 5, and I have only 4 numbers that are less than 5. So these 4 numbers must go in these 4 boxes. So this 1, 2, 3, 4 must go in these boxes, right? Similarly, let's start here 7. So the arrow is pointing this way, so this must be greater than number 7, right? And then arrow is pointing towards this way, so this number must be greater than this number, so this number must be greater than 7 too, right? Then these two numbers must both be greater than 7, right? And I have only 2 numbers that are greater than 7. So 8 and 9 must go in these 2 boxes, right? Then what is left? The only thing that is left is 6. Then 6 must go here, right? Then D is the correct choice. One bonus point. As you can see, all the arrows are pointing away from this box, right? The arrows are all pointing away from this box. So this must be the smallest number. This must be 1, right? Similarly, if you look at this box, all the arrows are pointing towards this box. Nothing is going away. So this must be the largest number. So this must be 9. But we don't need to know that, right? We only need to figure out what goes in the question mark, and that we already figured out. But I thought I would just point that out. Martin placed 3 different types of objects, hexagons, squares, and triangles, on the sets of the scales as shown. All right, so like this. What does he need to put on the left hand side on the third scale for these scales to balance? All right, what does he need to put here so that this scale is also balanced, right? All right, so let's look at the scales that are already balanced. For example, this one. I can see that there is a hexagon on both sides. So if I take away the hexagon, the scale will be still balanced, right? So let me take away the hexagon from both sides. Now, this tells me that triangle is equal to 1, 2, 3, 4, 5 squares, right? Okay, next. Now, if the triangle is 5 squares, let me take a look at this scale, which is also balanced. So this triangle is 5 square. There is one more square already there, right? So that is 6 square. What is this equal to? 2 hexagon, right? There is 1, 2, 2 hexagon, all right? So let me draw this. So 2 hexagon is 6 square. That means 1 hexagon will be half of this, right? 3 square, right? All right. So we have 1 hexagon is equal to 3 square, 1 triangle is equal to 5 square. Now let's take a look at this scale, right? So there are 2 triangles here. So 2 triangle equal to 1 triangle is 5 square, 2 triangle is 10 square, right? So 2 times this, right? 2 triangle is equal to 10 square. All right. So what do I have on this side? There are 3 hexagon. So 3 hexagon, but 1 hexagon is 1 hexagon is 3 square, 3 hexagon will be 9 square, right? 1 hexagon is 3 square, so 3 hexagon will be 3 times 3 is 9 square. All right. So I have 9 square on this side, 10 squares on this side. So what do I need to put here? I need one more square, right? So I need one more square to balance this scale. That means A is the correct answer. So one question you may have in your mind is, how do I know how do I solve this, right? Um, One thing is, if I need to balance this, right? So if I can express this in terms of a common shape, then I know I can just count it, right? And then I know how many of that common shape is here, how many of that common shape is here, and then I'll see how many I need, right? So in this case, I'm trying to represent everything in terms of the square, right? But mostly this comes through experience. Like if you solve problems like this, it will come to you automatically. Like here, if you just take a look, you can see that which of this balance scale you want to solve first. In this case, this one, because then I can cancel the hexagon and then I can just represent triangle in terms of squares, and then take that triangle, put it here, and then I can represent the hexagon in terms of the squares, right? So now I have both the triangle and the hexagon in terms of the squares, put it back here, then I can just count it. So basically it just comes mostly from experience. Solve many of these problems and then it will come to you. Thank you.